Alrighty, so we said our first one was this one that went with the 73.20. And then my second, and if you would have done these numbers and switched them, it wouldn't have mattered because 2 times 3 is 6 or 3 times 2 is 6. And then my other one was 26.80 times, didn't give myself enough room, 36.96. And then I would have divided all of that by 100. And then y'all told me we got 35.49 or 35.50. And then my units are AMU. All right. So remember, it's just always percent times the mass. And you have to do that for each isotope. All right, I gave you a little short packet of notes that you can put with your other ones. And it's just about counting atoms. So like I said, this may be a repeat, but I just thought we would refresh our memories before we do molar mass tomorrow. All right, so we're going to talk about counting atoms in a formula. Tyreek, could you sit up, please, sir? Tyreek, sit up, please, sir. We're covering something new. Sit all the way up, please. No, sir, sit up and get your notes out, please, sir. It's really easy. Not something you want to get a 0 on. So chemical compounds are represented by formulas that tells you how many atoms are in there. And we figure that out by looking at the subscripts. And remember, these small numbers, those are our subscripts. And they affect only the element that's in front of it. So this 2 only affects my hydrogen. This 4 only affects my oxygen. If there wasn't a subscript like this sulfur, there's no little small number behind it, then what do we assume is behind it? If there's no subscript, then we assume there's just a 1 because we never write a subscript of 1. So if we look at this particular one, this is sulfuric acid, I'm sorry. Every time I have a new element is when I have a capital letter. So in this case, I have hydrogen, sulfur, and oxygen. And then to count how many I have of each, I'm going to look at the subscript. So this 2 affects the hydrogen, so I would have 2 hydrogen. There's no subscript, so it's an assumed 1 for the sulfur, so I only have 1 sulfur. This, which one? Subscripts. And the 4 only affects the oxygen, so I will have 4 oxygen. Now, there are some other things that'll come up that'll change that up a little bit. But this is important for doing molar mass, which is what we're doing tomorrow. It's also important for doing, for balancing equations, which is what we're going to be doing also as we move throughout the year. All right. So here we have a formula for a compound that has carbon, hydrogen, and oxygen. Once again, every capital letter is a new element. Now, this one doesn't have any parentheses. It doesn't have any coefficients. All it has are these subscripts. So these subscripts are what I need to be concerned of. So once again, they affect the element that's in front of them. So if that's the case, I would have 12 atoms of carbon. The 22 affects the hydrogen, 22 atoms of hydrogen. The 11 affects the oxygen, so 11 atoms of oxygen. If there is not a subscript listed, like I said, then we assume it's a 1. So here, this is sodium chloride. That's table salt. 2 capital letters. So 2 elements, sodium and chlorine. Since there's no subscripts, I just have 1 of each of those. Just to a different number that shows up better. I should think that might show a little bit better. All right, so why don't y'all take a minute and practice these 2. First of all, the important thing is to identify your elements, and then I would make a little list down here. And then to the side, put how many you have of each. Yes. And it really doesn't matter how many you have total. Really what's important is for each element, how many you have. So like Kevin said, this one's pretty easy, right? How many sodium do I have? Na. 1. How many hydrogen? Carbon and oxygen? 3. And then over here, hydrochloric acid, 1 and 1. So that was a nice, easy one. I gotta do this. Now, if we put something into it like a parentheses, because a lot of formulas have parentheses, the parentheses will have a number outside of it. That number only affects what's inside the parentheses. So in other words, PB, which is lead, it's not affected by this 2. For the oxygen, it would be 3 times 2. But for the nitrogen, remember there's an assumed 1 right here. So it'd just be 1 times 2 on that. So if you have a parentheses, you're going to do subscript times subscript. So once again, our lead is on the outside. It's not affected by that 2. So we only have 1 of those. Once I start and I go inside the parentheses, I'm going to do subscript times subscript. Even though it's never written, we assume it's a 1. So 1 times 2 is where I get my 2 nitrogen. 3 times 2 is where I get my 6 hydrogen. Not too bad. We'll look at some more of those. All right, so let me do another one of these and then y'all can try one. We'll do this one. Now notice this 3, like I said, it doesn't affect anything behind it because those are not in the parentheses. This 3 affects my nitrogen and it affects my hydrogen. Once again, I'm going to see my elements. I have 4 capitals, so I have 4 elements. You don't have to write out the names. You can just put the symbols. So I'm going to start with my nitrogen. It has that assumed 1. So it has 3. 1 times 3 would give me 3. Hydrogen, 12. 4 times 3 would give me 12. Now I'm through with the parentheses. So how many phosphorus do I have?
1.
Just 1, exactly. And oxygen, 4. All right, why don't y'all give that other one, magnesium hydroxide, a try? Honey, did you get the worksheet too? Did you pick the worksheet up too? If you remember it from, you can go ahead and you don't have to do on that little worksheet. It shows like at the end you have to total up how many like totaled up. You don't need to do that because that really doesn't ever really become important. All right, how many elements do we have here? Right, magnesium, oxygen, and hydrogen. Those two are separate, okay, because they're both capital. So how many magnesium do I have? Like you said, one, Summer. How many oxygen do I have? Two, and two. Perfect, all right. We already did all that. All right, now we got the very last thing. Now we have what's called a coefficient, which are these large numbers. And a coefficient affects everything behind it. So that too affects my nitrogen, my hydrogen, my phosphorus, and my oxygen. So I need to figure out how many I have of each one based off of the other rules. And then when I get that total, I come and I multiply it by the coefficient. So I have 4 capitals. So that's why I have my 4 elements. So to start off with, I have my nitrogen. So I'm first of all going to do what I would do with the parentheses. So even though it's not written, we have an assumed 1. So I would do 1 times 3. And then 3 times 2 exactly would be my 6. So you do what you would do within the formula and then multiply it by the coefficient. So for my hydrogen, I would have 4 times 3 is 12, and then 12 times 24. How many phosphorus would I have? 2, because I have 1 here, and then 1 times 2 is 2. And oxygen, I would have 8. Same thing, magnesium hydroxide, 3 capitals, 3 elements. So first of all, for my magnesium, how many would I have? 2. Oxygen, I would have 4, because I have 1 times 2 is 2, and then 2 times 2 is 4. And hydrogen, I would have 4. Same thing, even though it's not written, it's assumed 1. So 1 times 2 is 2, and then 2 times 2 would give me my 4. And coefficients are what we'll be using when we get to balancing the equations. All right, why don't y'all give a couple of these a try? Why don't y'all try, this one's probably the hardest one. Why don't y'all try this one and give that one a try? Those two. Oh, my nose is itchy today. You sure I get that for you? Huh?
It's on the shirt.
It's her shirt. How's she doing? Tell her I said hi. Do you see her a lot? Do y'all live together? I mean, do y'all's families live together?
No.
No, but by each other. All right, so I'll start with my first one. This is phosphoric acid. So 1, 2, 3 capitals, so 3 elements. This one only has subscript, so it's a little bit easier. How many hydrogen do I have? 3. Phosphorus?
4. And then 1.
Just 1. And oxygen would be my 4. All right, this one's a little harder because I got some parentheses and a coefficient. Once again, 3 capitals. So for my calcium, how many would I have? 6. That's right. 3, and then times 2 for phosphorus. 4. Even though it's not written, it's an assumed 1. So I would say 1 times 2 first, and then 2 times 2 would give me my 4. And then my oxygen?
16.
16. Perfect. 4 times 2 is 8, and then 8 times 2 is 16. All right. So if you will look at your worksheet, then that's all it is. It's just practice on that. Let me get out of here. Out of there. All right, class period. I dream about Google Classroom at night sometimes in my sleep. All right, so those top ones are just examples here. Now, what you don't have to do is you do not have to give me the total. You can just do what we were doing on the practice, because really how many total we have of all the elements doesn't really ever come into play, okay? So this is the exact same thing that we were doing. Here, the examples, they already have the elements listed for you, but here, down here, you'll have to find your elements. Remember, every capital letter is an element. So in this case, I have sodium, oxygen, and hydrogen. And then how many do I have? Just one of each. And that's what you need to list. You need to list the element and how many you have. You don't have to worry about then totaling them all up. All right. And I will come around and see if anybody needs any help on it. And we will put that into play tomorrow when well, it may be Monday, depending on how far we get after the quiz, but on molar mass.